When the Earth was formed, there was no life on the planet until proteins got together correctly and life burst forth. For many billions of years, life on Earth was uninteresting and simple. The oceans were packed with simple single-cell organisms, and it remained this way for many years. Then life got more interesting as organisms began to get more complex and had more than a single cell. They grew larger, up to 10,000 times bigger by volume, according to Professor of Evolutionary Chemistry, Nick Lane, from the University College London. Increase in complexity and size was an important step to existence of humans. This step was one that was important, and the sudden increase in the complexity and size is something that cannot be overstated. Without this step, more complex life, such as human beings, would not exist. Just how this step came to happen is one of the biggest questions in evolutionary biology. There are many theories as to how life managed to get so much more complicated. One theory that Lane has is a focus on energy. Cells need energy in order to be able to build structures that are more complex. The theory of Lane is that single-celled organisms manage to merge with bacteria called mitochondria. This has an electrical charge and brings power to cells, and it is possible, although not very likely, that the two bacteria fitted together and was able to survive and live, which is even less probable. The happening may have made possible all forms of complex life is rare, but Lane believes that it happened once. Everything came from merger of two cells. Lane said that it comes down to a merger of two cells, which then became one, and then everything came from that. This includes humans, birds, fungus, algae, every type of life that can be seen, and even those that we cannot, all came from that single cell. When considering how life got so much more complicated, it is important to consider the history of life on Earth, and it could help to inform the search for life on other planets. Complex life is very rare, but does this mean it is less likely for people to find intelligent life in the universe? Instead, should we look for something that is smaller and much simpler? Could it be possible that the universe that is outside of Earth is only populated by organisms that are single-celled? As the specific conditions are unlikely, is it also possible that complex life might exist only on planet Earth? Mitochondria helped with evolution of organisms with multicells. Experts have debated the theory of Lane and asked if they think intelligent extraterrestrial life is possible. Professor of biology at Duke University, Mohammed said that he thought Lane's theory was true. He said that mitochondria arrived in the ancestor of plants, animals, and fungi a long time ago, and it helped facilitate the evolution of organisms with multicells. He also said that there is a single common ancestor in all life on Earth, and it is carbon-water-based and was replicated by nucleic acids and lived in conditions that existed on both ancient and in modern Earth. He went on to say that if life had arrived on a world that was much colder, other parameters in the environment would be different. The director of research at the Mathematics Institute of Marseille said that the symbiosis between eukaryotes and bacteria had happened numerous times throughout the evolution of life. He said that cyanobacteria merged with plant cells and then became chloroplast. If the organisms such as bacteria and eukaryotes were present on any other planet, then symbiosis would happen. He said that they did not have any other information about the type of life that might exist on other planets. However, planets and galaxies had managed to evolve a great deal throughout the history of the universe, and so it may be possible that life would too. Free oxygen-fueled combination of pre-mitochondrial bacterium and pre-eukaryote. Senior scientist at the SETI Institute, John Rummel, said that with the advantages that were offered by the symbiosis of pre-mitochondrial bacterium and pre-eukaryote, it might be possible that only once would have been enough, as free oxygen might have been present, and this would have fueled the combination. He went on to say that we have no idea where and at what the eating of pre-mitochondria scale might have become popular on planet Earth. Biochemistry is the key to whether or not it is advantageous, and whether or not it is widespread in the cosmos is a question that is more biochemical than a natural science one. With the advantages of mitochondrial, it may have been quite a struggle for an complex biochemistries to develop that would be able to support the evolution of intelligence on a world that was physically challenging, but not entirely impossible. 1400974